Now we're going to talk about interference. Interference occurs when you have two waves in the same place at the same time. You can have constructive interference where the waves are heading towards each other. Say this is wave A, and let's say wave B is going this way. When they're in the same place at the same time, they add at every point. You get a higher wave. This is A plus B. This is constructive. Destructive interference is what happens when they're on opposite sides of the equilibrium line. And let's say A is going this way and B is going this way. Then at this point in time, if their amplitudes are the same, they cancel each other out. This is destructive. Now partial is what happens when you have, partial. Suppose I have one wave that looks like this and another wave, let's see, that looks like this. All right, when they get in the same place at the same time, oh goodness, who knows what this will look like. All right, so we're going to use the Colorado FET, a wonderful program. Those are PHET, Colorado, to do some demos for this homework. Now draw an example of constructive interference. Let's see if we can show constructive interference. Here is the FET I told you about. Now remember, what we're going to do is, let's see, we need to get this up here. All right, we need to have, let's just play with this for a second. If I do a pulse on a free end, you see it reflects on the same end. This is a fixed end. See, for a fixed end, it reflects on the opposite end. So remember that. See, if it's, let's go to fixed. If it's fixed end, it's always going to reflect on the opposite end. Opposite. Or if you have a loose end, it's going to reflect on the same side. Let's see. That's not what we're doing. Let's do some constructive interference. So what I'm going to do is I'm going to give it a pulse. Now watch what happens. Do you see when they're in the same place at the same time, how it gets much taller? Right there. All right. So an example of constructive interference is exactly what I drew on the front page. This is wave A. You really don't have to draw them backwards. And this is wave B. They have the same shape at the same time. When they're in the same place, then just twice as tall. This is A plus B. They're on the same side of the equinodal line, and it's twice as tall. Destructive interference, well, that's when the wave is going to the right, and wave B is going to the left. Draw on your arrows, but they're on opposite sides of the equinodal line, and so they wind up canceling each other out. What's the difference between complete destructive and partial destructive? Well, here you get partial destructive whenever you see this is all partial. You're neither completely adding nor completely destroying the wave. And I love doing this. I could do this for days. This is just too much fun. Okay, I'll behave. All right. So complete destructive means the waves completely cancel at that point in time. For partial destructive means, let's see, let me do a diagram here. This is complete. Where partial is when the waves only partially cancel. Seriously, this is what it means. An example would be like this right here, a really tall one, and then a really short one, so that when they're in the same space, oh gee, what would this look like? It would only be part like that. Now, draw an example of a wave that goes down and is reflected at a free end. You remember, when it's at a free end, what's it going to do? It's got a free end, it's going to reflect on the same side. Same shape, everything. Let me give you a manual. Let me show you what happens when the wave is not something really nice. Okay, that one's actually really nice. So let's restart that. Let me give you kind of a funky one. Do you see how the wave has the same shape? Let me restart that. Okay, so it's got this. Hold on, let's go back to the fixed. See how it's got that wave? It's got the tall and then the smaller ones following. All right, it has the same shape. So you don't have to do anything that fancy. So if it goes down, just do it right here. If it goes to a loose end, it's going to hit, and then say the wave is going this way. When it hits, what's it going to do? Well, I'm going to undo that because that was wrong. It's going to simply reflect back on the same side. Here's the loose end. It's going to reflect back on the same side of the equinoctial line. Now, what if it's fixed in? Okay, well, let's restart, and let's go to a fixed end. Remember, on a fixed end, what's it going to do? It's going to reflect back on the opposite side. All right, so for this one, suppose I have a wave going this way. When it hits the fixed end, I don't know why I keep doing that. When it hits the fixed end, what's it going to do? It's going to reflect back on the opposite side.